Started 9:59. After all that hubbub. So I just want to welcome you all to HCC. I think some of the panelists been here before, but Maury has been here before, but sometime today you want to, especially your foreigners, want to take a little tour of the lab to see what kind of equipment we work with in the engineering technology associated science programs across the state. Most of the colleges all over, about almost 20 of them or a little bit more than that, have labs that are similar to this or have the equivalent equipment. And so it's really a good opportunity for you to see what we do in those colleges and be able to share that with your colleagues. So you can go to the schools and hire our students, put them to work at a different level. You know, most of them are in school for 2 years, so they learn a lot and get a lot of hands-on equipment experience. So today, I won't say too much about that. Today we're here to start our project with the LIMS boxes. I think everybody's a little familiar. Did everybody watch the videos? Yeah. All right, that's great. And the idea of what we're going to do with this little project, first of all, I want to thank the MEP America Works unit for providing us with $10,000. I got a small grant to support the first efforts on these devices that you'll be taking back to the colleges. So that's HCC, Central Florida, and Ocala, Polk State and Polk County, and Cecilia at Seminole State. And theoretically, Nancy from the USF will be here at some point today, and I'm going to try to connect them with the HCC group. And the money that we got was to help buy some supplies, probably sensors maybe that you might need for a project, to support, give a stipend to a student, and also for you dedicated faculty, a stipend for the faculty as well. And just in brief, there'll be more about all these details coming, but just in brief, the output is a project with a little video demonstration, you know, I don't know, a couple minutes by the students, and like a demonstration brief, like a one-page demonstration brief. And then we'll have a little expo next fall at the Florida Makes conference with some of those demonstrations. So it's a great toy to get to play with. And Mark Medor here from Florida Makes, he's in charge of the business advisors. Those are the people who go out around and try to help businesses improve their business, manufacturers improve their businesses. He's actually very familiar with all this from the company that he ran for a number of years. And he's on my backup team for making sure that manufacturers get connected to this and some of the demonstration projects that you'll be doing. So we're hoping to get some better connections between the industries in our state and the colleges and the college programs, and be able to help each other with all the things we know we can work on together. So with that, I'm going to stop talking and turn it over to who's going to talk first.
Stefan, if you want to just introduce the AMI really quickly, and then I'll talk about what we're going to do today. Yeah, turn over to Nat.
So just very briefly, AMI, Advanced Manufacturing International, is a not-for-profit company we founded about 1.5 years ago. We are dedicated to helping small medium manufacturers with a digital transformation. That's our mission. It's a 501c. And besides having the product we're talking about here, we also are doing workforce training, and we have a membership program, the Smart Manufacturing Leadership Coalition. And we're excited that you're all here, so thank you for coming. You are the first group we are giving such an extensive training to. And so forgive any glitches, we're going to try to do the best we can. Of course, we would be happy to take any and all feedback from you to make it even better the next time. Larry and Nat will do the bulk of the training. Dan Nagy is our VP of Business Development. And we have Nat Frampton, who is sort of like the inventor of the box. whom we are working with, and he'll talk a lot today. And then we have Tim DeMars here, who has the rough assignment of doing this from the Cayman Islands. You know, we're all thinking, tough job, Tim. You know, sorry, but somebody had to be there.
Are you hiring?
Yeah, but only in Hawaii.
I'm willing to step up for this assignment.
Yeah, so Tim is really instrumental in helping us implementing those boxes, and you know, he's taken his annual vacation there in the Caymans. So thank you for doing that from your vacation. So I hope you're going to have all time. I hope you have a good time. I think we have like 4 or 5 hours or so to do this. And there's a question, please go ahead.
Yeah, when you say that you work for certification
Yeah.
stuff, are you following any particular certification, or do you have any certification yourself?
We do not have a certification. So basically, as Stefan said, AMI is a new organization, trying to help the small and medium manufacturers. We see this product. We are helping basically market this product for both that marketplace as well as the educational marketplace. And so we see this product as a great entry point. We talk about digital transformation or smart manufacturing. And so we want to build a workforce program side of in parallel with that. And so we're looking at funding sources and so forth. So the short answer is we're actually looking for partnerships to help us build that program, build that curriculum, whether it be for the manufacturers or whether it be for educational.
So one of the things we're doing, we're working with the University of Tennessee, Tony Schmitz, so you know, to create a set of instructional videos to do this. And we are partnering with SME, Society of Manufacturing Engineers, on the Tooling U platform to distribute that. Could we get to a certification? Of course we could, but we wouldn't want to do that ourselves. We would absolutely do that in partnerships with universities and maybe SME or other partners who are interested.
I would say probably SME.
Yeah. We think extremely highly of this. We had the last couple of presidents of SME were board members of ours or running the company now. So we have a very strong relationship with them. They're very interested in doing that with us. But that's not to say that we would just do it with SME.
Yeah.
We would also look for university partners to develop content.
We are SME members. And,
Right.
we know.
I couldn't think of a better organization to help with this endeavor. Any other questions?
I just want to know, with your experiences going on, I know that we're seeing that a lot of our local manufacturers are not even close to Industry 4.0.
Yeah.
And it's a time-oriented thing. It's not going to happen overnight.
Right.
The cost is too prohibitive. So if you add one of these in, how are we going to get a company to move that direction? Do you guys help with that?
Yeah, so that's really the goal.
Okay.
So so I worked for a couple big companies before. My last job was IBM, and I was running the AI and IoT product management. And I tried extremely hard to go down market. So we had about 4,000 clients, including General Motors, General Electric, Lockheed, all the big guys, right? And so I just couldn't move it down market because it was impossible to get the cost at a point where the smallest could afford that. Now we are running a non-for-profit. Nat is helping us with a very low price of the box. And so what we're really shifting is we're shifting the cost curve and keeping the benefits curve nearly constant compared to the big guys.
Okay.
And so I worked 15 years for General Motors. We did it there. The ROIs are fantastic.
Yeah.
As soon as you can scale, right? Which is hard for small medium because they're one shop. Well, how are they going to scale, right? And so by offering standardized offerings that are simple to install, simple to train, and ultra low cost, we think we can crack that nut. But that's just the cost side. The maybe even the harder side, as you said, is they're not even close because they just don't know how to start. Well, Industry 4.0 is just a word.
Well, I think what's happening now is they know they're going to do it. What issue we're running in our area is here, not as much as here, but small mom and pop shops are no longer, you can't find employees because nobody can go to work for whatever reason. And so what they're doing is they're looking at more automation. I'm getting a lot of calls for
That's
collaborative
right.
robot training, and I said, are you going smart factory or no? And they go, what, you know.
What is
well,
that?
if we could afford to, we would. So this is what I'm looking at.
So that's really the goal of this. And so
It's great.
we're not making any money on the box. We're not making any money on the service. But you have to think about, so it's the box, and then somebody has to come and install it. So that includes travel and this and that. So you will reach like 25 grand.
Yeah.
So you have to look at that. But it's not like a 6-figure, 7-figure installation that the big guys are. Right?
So if we train our students to do this, and they don't need to go outside, and we hire our students. to come in
And
and-
so if you don't, right, so that's another great way of doing it. I think of it just like, when I was a student, there was, so I was in statistics and operations research. And so there was like SAS would give you a free copy, and those guys would give you, free copy of this. And so what do I do? So when I joined General Motors, the first thing I asked is, well, can we buy the software? Yeah, sure, because I'm already trained on it, right? So, and so we are thinking of it the same way. We think maybe we can train students on this. And that would then allow them, when they take a job with a small, medium manufacturer, to say, well, I know this already, I can implement that, it's easy for me to do, it's open standards, it's as cheap as it gets. And that then would reduce the cost even farther, because now you only have to buy the box, because we're not interested in the service dollars, we're just interested in the mission we're trying to fulfill,
that's
right?
it. I got you.
So for universities, we sell it for $5 grand, and we say, well, $4,995, so that you don't meet the threshold that matters for some. And then, well, your grad students figure this out. We give you a couple of hours of training over the web, but that's it. So that's what you have to deal with. But if you're a small manufacturer, typically you can't do that. You have to do the first installation, train the IT folks, train maybe one or two of the engineers, that they can subsequently do exactly what we hope they will do. Is that good?
Yeah, I think I got it.
I'm gonna
I
jump
kind of
in.
got that.
So, yeah, exactly. So any questions like that around what we're doing, mission, happy to talk about just as the day goes on. I wanted to get going because Nat has a time constraint this morning, and I want to make sure. So we'll cover that. So just really quickly in terms of agenda for today, again, Larry Megan, if you haven't met me, also with AMI, with Stefan. Basically, agenda for today is, as Stefan mentioned, Nat is the brains behind the LIMS platform. It's hardware and software. It's an integrated platform. He'll describe that. He's the inventor of that. So we're going to have him do kind of the introductory training for that, a little bit more classroom style. And then after that, we're going to, while he's doing that in parallel, I'll be going around and setting up stations. So ignore me as I'm walking around trying to connect stuff. And then after that, we'll do a few exercises, after lunch, or we'll kind of work on the fly here, but we'll do a couple exercises about hooking up sensors and using the interface and that kind of stuff. The objective for today, of course, it's a platform with a lot of capability. You're obviously, like anything, you're not going to learn it all in a few hours. So the goal for today is to really create a level of awareness around what it can do, or get you thinking about, hey, what could I do with this, right? And so, that's your homework assignment for Maryland anyway. And so, be thinking about that as Nat is presenting, and this, we're doing a couple of demonstrations. And then, what will ultimately happen is a follow-up, really with Tim's help, is to follow up with the teams individually to say, okay, now we have a picture of what we want to try. And we'll help you then kind of walk you through the details of that, right? So again, today, really introduction, kind of get you a little bit comfortable with what's there, get your hands on it a little bit, and then we'll kind of go from there. Okay. Okay, Marilyn.
I think we should go around and at least give first names and where people are from. We've got our last group here from USF. So we'll start with Nancy.
Hi, everybody. Pleasure to meet you. I'm faculty in the Department of Mechanical Engineering and Institute of Management, and we do research in smart and sustainable manufacturing. And I'm here with PhD students Donald and Johanna.
Yeah, Donald McCreary, got my master's degree in South Carolina. Moved here for my PhD. Nice to meet you.
So I'm Avraj, got my master's degree in material science and engineering. I'm currently doing my PhD in mechanical engineering, working specifically with tool condition monitoring. So that's my research area. Nice to meet you.
Attorney friend with Blake.
Teresa Potter with Blake.
Maryland.
Christopher Krupke from the College of Central Florida.
My name is Professor, I'm Sam Osmond, I live in engineering technology, Central Florida.
Shirley Dobbins here at HCC.
Engineering technology.
Oh, yes. So we have our, we'll get to our president and my dean is just here as well. So please.
Hi.
Hi.
Thank you. Thanks for letting me up. I didn't want to interrupt. I'll apologize. My name is Brandon Rockwell. I'm the AS dean at Brandon. I oversee the engineering as well as computer science area. I also have an expressed interest in this stuff because I like Raspberry Pi projects. I've been doing those for the last, since the Raspberry Pi came out. I was computer science faculty for the last 12 years as well, so directly using some of the stuff. But it's very nice to meet you. Hopefully I'll get to interact with some.
You're welcome to hang out.
And we also have Mr. Rand, who's our AA.
Hi, I just kind of want. That looks great.
Thanks for hosting.
Yeah, thank you.
And welcome.
Thank you.
Yeah, I'm Ron Smith. I'm the other half of the engineering technology faculty here.
And our host with the most is today.
These are.
Hi, I'm the lab technician for the facility. Oh, I'm sure.
He's being modest, he's way more than the
Oh,
last.
yes. He makes things happen here, okay? He's doing that good work.
Mark?
Mark Fedor, Director of Operations with Florida Makes. I manage a team that interfaces with all the manufacturers throughout the state. I'm Richard Gilbert, I interface with Flake. I also have a SFATE project that can use this technology.
Come over here.
Yeah, I'm Dan Nagy from AMI.
Stefan Miller, good morning.
Last, not least.
Yeah, morning, 2C, folks, stay silent.
Awesome. Okay, and we have a couple, maybe we should go through these people that we have here on.
Sure, do we want to introduce him?
Introduce a couple that,
I'm gonna let Nat introduce himself in a minute. Tim, do you want to introduce yourself? You're muted.
yeah.
Here I am prattling at my own image. Tim DeMars, I'm working with AMI, primarily with Nat in the field on field installations and the technical end of the product.
Thanks, Tim. David?
You there, David? We come back. later.
No, we'll come back. Cecilia?
Hi, I'm Cecilia Larsson. I'm a program manager at Seminole State College.
Great. All right, Nat, I'm going to turn it over to you, and it's all yours.
All right, great. I have a little difficulty hearing questions from in the room, so they may need to be echoed if anyone has them. The mic isn't directional, so we'll see what we can do. But good morning to everyone. Thank you all for taking some time to hear about AMI's initiative and how that partnership can help manufacturing in Florida. That makes a great sense. I'm a mechanical engineer by training, so I shouldn't be telling everybody about software and electronics, but I'm going to do it. They gave me the mic. I am living in New Jersey. I am a recent transplant from Miami and Orlando. So I lived in both of those places for a couple of years over the last 5 or 6 years. So great to see everyone and the amount of work going on there in Florida. I should have stayed, right? So that would be good. Anyhow, thank you all for having some time to listen to what this product, which is in AMI's charter, which is to help raise the capabilities of small to medium manufacturers, and doing that as a not-for-profit organization. I have been working with their parent company, MTDG, and their sister company, NCDMM, for many years, doing and deploying technology. And I have spent my career taking that technology and packaging it up. So I started off trying to sell software. That really goes over well in manufacturing. You bring in a CD and they throw it in the trash, right? But if you bring in a box, That was the change. That was the aha. If I take all the software and stick it in a box and give it to them, and it looks like other boxes they have, it all starts to work. So that was the birth of LIMS. And I think Stefan is credited here with the low investment manufacturing system. So that I had a much more complicated name. Again, I'm not in marketing or anything like that. So I had a much more gobbledygook name. So we're sticking with the low investment manufacturing system, which makes sense. And it's an edge appliance. And we'll say what the heck that means. If I do get stuck behind an acronym, call me on it. If I don't tell you what it means, please ask. So that'll be good. So what is LIMS, this low investment manufacturing system? It's a computer. And I heard somebody who likes Raspberry Pi. So the nice word is there. It's a Revolution Pi built by an IO company in Germany. And it's built with all of the quality of industrial IO system. So that's why I've selected the Revolution Pi as the platform in which we run. We have over the years had many computers, and the computers change in and out. So it really isn't about the computer, but the computer is a platform. So if you're already doing work, I hear somebody in the crowd likes to write software from the computer science area. We understand that, and that's what the computer is for. And we'll talk a little bit more about how you can get started on that. It's in industrial packaging. So I've spent the last 20 years doing things from chocolate factories to roller coasters to the World Trade Center to all kinds of different projects. And it's interesting because I've used one tool, one piece of software to do all of this, and one industrial packaging now over the past 15 years, which is this LIMS box. Survive steam leaks in buildings, survive being covered in chocolate on a little problem they had there, but it is an industrial packaging, and will be very familiar to anyone who's doing maintenance or anything like that. And its key is it's running some software. That's the key. It's not just a computer, but it's some software focused on the manufacturing personnel. It's made to be run by somebody who just understands how to use a computer. It's designed to help you understand your equipment and improve your process. And I call it a manufacturing Swiss Army knife. It'll get you in. We do a lot of work with large companies, and you're like, well, why would they need such a simple little box? Their biggest problem is the Swiss Army knife side. Getting into old legacy systems, having a little bridge between a system where they already paid for all the IO they're going to get and needed to add just a little bit more or get some more information from it. So I designed the software in response to seeing the US Army have to pay $400,000 to have a plant with the same equipment changed to do another product. And the software was already written. It was $400,000 to change it over from one to the other. And that just didn't seem to make sense. So the first thing we started to do was to look at the industrial networks, pull the logic back out of them and put them in a computer and in software. And that software is called Solution Family. So you'll see that word intermixed here a little bit. You might even see a sticker here and there on the LIMS boxes that says Solution Family. And that's the name of the software. And then remember, I was trying to sell software. Didn't go so well because people didn't know where to stick the software. So you had to give them a box with the software already in it. So how can it help me? So I've got a box. Okay, now I got a box. It's got a computer in it. I get it. And what's it going to do? And it basically connects to your equipment. So if you've got some equipment that already has some intelligence, great. If it doesn't have any intelligence, we'll add sensors and try to figure out what it's doing. Add sensors for things you want to know. I want to know the temperature of that. I want to know the humidity in the area. I want to know whether that door right beside my piece of equipment is opened in the middle of summer and the humidity goes crazy and I can't make good parts anymore. Collect data any way you want to see it. I don't want to prescribe, here's what's going to happen. What if you wanted to look at a bunch of different systems working together? A student says, hey, look, I'm designing this new sensor. I'd like to have that sensor run along with this existing system. Could I collect both pieces of data at once? handles in these systems, we have reporting capabilities. You can report back up to the AMI cloud. So AMI has their own cloud. You could move data back up to that and access it over history. So it does that automatically. Number one ask for manufacturers, can you tell me at 2 in the morning when my print job stopped? Can you tell me when my machine tool shut down? I'm just running it and I go away. This happens a lot in 3D printing. We're doing a lot of work there. And most importantly, the software and the platform was designed around explosive manufacturing for the US Army. So I did all this work in New Jersey starting 20 years ago. And the most important thing, and I'm a controls engineer by training, is that it controlled things. And control is interesting because you could say, well, I'm not going to go in and control the equipment, but you may change what data you're collecting based on where the system is currently at. What's it working on? I want to collect this data or that. That's some control. Sending me an email. Maybe putting up a light like you see on the system behind me. If we turn on a light, let me go up a little bit. But you might just have a simple light that's flashing on or off or telling you that, hey, that door is open. You're in a state where the system doesn't run well. So just notifying you. And sometimes you have a light until you get, trust the light enough where you say, okay, I'm just going to turn off something. So let's say at 2 a.m., my print job stopped. So I'm going to go ahead and pull the relay on the oven that was preheating for that part after it's done. So I'm going to save the energy from doing that. So we want to control the equipment. So that's an important part of the process. That requires a little bit more training, but most importantly, it's digitizing so you can improve what you do. And that's connect to the equipment, get the sensors in, all of that kind of stuff. But most importantly, do this with the computer skills you already have. I don't want you to have to become a programmer. If you are a programmer, great. I got a way for you to get connected. But most importantly, I want you to be able to use an appliance out of the box fairly quickly with equipment that you might have, and to be able to get some data back out of it and start figuring out, learning about your process so that you could improve it. So there's a lot of different places that we go into. And one of them, obviously, you're going to have manufacturers that are saying, you're not getting no data is leaving my floor. Or I've got an IT group that's paralyzed by the thought of any system coming in and possibly pushing any data out. So one of the areas that we work in is what we call air gap. And that just means there's no data going out of the system. And that's what's unique about the LIMS box. One of its main features is that it was designed as a control system first. So it doesn't care whether it's connected to a network, a cloud, or anything like that. What it wants to do is connect to your equipment. So what you may do is create your own isolated network, connect the LIMS box to it, connect your equipment to it, and all of a sudden you are getting data, producing data, and storing it. So all of that I call air gap. And that just means there's literally air between your data and anybody outside. The more interesting piece is that the LIMS box on that computer has 2 network connections. Why is that important? Well, what we feel is that the manufacturing equipment should never be exposed to outside networks. It should never be on the internet, because some of the equipment is designed to phone home, to check in with a server and decide whether it needs to be updated. And that's fatal. The other thing is we don't want IT doing updates on our manufacturing equipment. A lot of the equipment won't tolerate it. It may be old operating systems that can't be patched or, updated. So we want to create a bridge. We want the manufacturing equipment to be all isolated, and then connecting to data and responsibly connecting and not creating these big, the cool word they have is attack surfaces, right? That means how many ways can you get in and how many services are setting out there that you could come in and cause mayhem on your system. What we do, the nice thing about the LIMS box is it can create a single point at which that's the bridge between your manufacturing data and moving back up to the IT folks and getting data back up to them. So we work hard to make sure that that connection into the business networks has well-defined interfaces that keep you safe. We're working with NIST on the latest standards that they put out to make sure that you're going to be compliant to be able to do even DoD contracting. You'll have to be at a certain NIST level compliance. And we work with the box and work with NIST to make sure that that's happening. So air-gapped means we're not going to connect, but you still are fully functional. Bridged, yeah, you can do that, connect to databases and move data, but your internal systems are going to run whether or not somebody dug up your fiber outside your building or IT decided that they were going to do some update and you don't have connectivity to your business network anymore. We want the manufacturing network to run with no excuses, and that's the design of the system. Any questions on that? Okay.
Yell. Yeah, so where is the microphone? It's the big thing in the front.
Okay, relative to distinguishing the word cloud from the edge computing, does the box, and I understand isolation of the process and process control, does the box have a connection to the edge world? And if so, what interface does it use?
Okay, so we're going to go through the next slide. We're going to show all of the interfaces that exist on the LIMS box. So the LIMS box lives at the edge. And I'm sorry?
You got it. You got it. Keep going.
Okay, I think I was ready for your question. The edge is right at the edge. I mean, it sounds really cool and all of that kind of stuff, but it's right on the edge of the equipment. Sometimes they set us on top of the piece of equipment. Sometimes they mount us on the wall. Sometimes if they think they're not sure they're going to use this, they put us on a cart. And until we're good enough, they will not mount us on the wall yet. They're just going to keep us on the cart so they can get rid of us if they wanted to do it quickly. So the box lives at the edge of wherever they'll set us. The goal is to be close enough to wire into sensors that are going on there. If there is a connectivity to a business network, then we would go ahead and do connectivity on that second port to go out and talk to a database or to talk to Azure or talk to AWS. Internally, we have over 50 different protocols we speak to talk to manufacturing equipment. And you could call those edge protocols, right? It's manufacturing protocols. So if we're going to talk Modbus or OPC UA, these are a bunch of acronyms that float around just to be cool, but it's basically what you need to go out and talk to existing manufacturing equipment. We might be talking Ethernet IP. And again, if you have somebody that is into these, there's a bunch of acronyms up on the slide. If they have some they don't want, come in. I don't want to bore everybody with it, but the goal is if you have a piece of equipment that has some intelligence, we can probably connect to it. And we have an extensible system that even if we can't, if it does have some interface, well, you could write just a little bit of glue code and bring that data in. So you're free to extend it, and all of that's open source so you can go out and do your own work. We connect, we publish data into all kinds of different ways. So we're going to be publishing through MQTT. We do some Prometheus, which is real-time streaming. We talk to LabVIEW. We talk, anything is there. The platform itself has all different types of protocols, including a real-time extension. So if you wanted to do some real high-speed sampling of data and bring that in, you can run that right on the platform, right along with the software that I'm running on the platform, which is great. Connects to old wires like RS-232 or RS-485. If anybody knows what those are, well, we connect to those as well because we connect to old systems. We connect to databases like Oracle and SQLite and MySQL, so all of those databases, we check off those boxes. And then half your systems may not be intelligent. So you're going to need to add your own sensors to them. Or even if they are intelligent, most big expensive machine tools don't record their coolant temperature. They don't tell you what the motor case temperature is on the spindle that might be overheating. And we want to go sense that. So Larry, I shipped down some sensors. Hopefully they arrive FedEx overnight. I tried it already earlier this week, didn't go so well. So I sent another set out tonight, last night. And you're going to wire up some sensors and see the process of doing that. So you can bring in all kinds of analog values, any electrical engineers in there. We got 4 to 20 milliamp sensors and 0 to 10, 0 to 5, a thermistor, which is a real cheap temperature sensor. And I sent some of those down. And just, hey, whether a door's open or just a contactor closure. And it also has the ability to output and give you relays. And that's how the lights and things like that are firing behind me. So we cover the protocols. It natively talks from this box to the tool that's going to configure it via a protocol called MT Connect. So that's a manufacturing machine tool standard, and it allows you easily to be able to connect to data. And for the software folks, we have on GitHub, if you go to GitHub, we have a open protocols for any .NET developer, any Python developer, or JavaScript developer. We have open source out there for you to get up and running and being able to get data and contribute data back to this box. And we've had large customers, very large defense contractors, try to bridge a lot of their old projects and use those different languages to move data from their old projects into a platform where they can have data collection across different platforms and things like that. So students were my original target for all of this. I was looking at either undergraduate or graduate level courses in things like OEE, which is looking at the overall equipment effectiveness, how well your equipment's running. Hey, you paid for this equipment, how much are you using it? And this is an industry way to score how you're doing it. So it does that kind of work. So I did some coursework to make sure that people understood what OEE was, made students do it the hard way at first, calculate it on a piece of paper, right, to figure out what it was, and then enjoy having the system automatically do it with understanding, right? That's the whole point. So that's the interconnectivity of the device. It's got lots of Ethernet. It's a nice platform. You can run your software on it. And if you're already a Raspberry Pi person, you'll be very comfortable and already at home on, opening up Python and jumping in and, being able to connect and do all of the work that you want to do. Did that answer your question on connectivity?
It did, thank you.
Okay, great. So we use the term surrounded by standards. Wherever we can, we lean on a standard. There's no use creating a new one. And being able to get information back in any way you really want to see it. That's our goal, is to make sure that this is connectivity. But all of those things that I just described and all of that ugliness and all of these acronyms that I'm hiding behind, you don't need them to use it. You can just think about, let me connect to some equipment. I know a piece of equipment. I know that it's got a serial port and I'm going to connect to it and do that kind of thing. I think Larry actually brought down a 3D printer. And if you do have any desktop 3D printers, which almost most students have seen or have access to, it connects to most of the 3D printers, desktop 3D printers on the market out of the box, and allows you to do some really cool stuff. And I'll show you an example of that in just a second. So in order to be secure, the most important thing is that it doesn't open up a lot of ways for you to get in. And this is some networking gobbledygook, but this networking connectivity is the slide I use to talk to the IT departments. And that means that from this LIMS box, there is only a single port that you need to open up. And that port is no different than a web page from your printer. And you can make it any port number you want, but that helps the IT departments limit the conversation. And that's really what security is about, is making sure who's going to be talking, who's going to be listening, and how. And if I can limit that, and I can say only this computer is going to be talking to this computer on that port, it really allows them to lock this down. And that's how we're running for at Army facilities. That's how we're running on the defense research networks. So we tried to do this, and I know nobody's going to talk to us if this isn't secure. Nobody's going to even let us in. And so what we've done is try to take care of the security problem first. And a lot of these small to mediums don't have the personnel to do this, right? They don't have the ability to go hire somebody that's got to come up to speed in acronyms to be able to do this. The goal is, okay, I've got a pretty smart operator that likes, just to use computers a little bit. Well, that's really what we need. We turn on somebody like that and enable them and empower them. And then we take care of the technology behind the scenes. And then if we do go to the cloud, we'll give you exact location we're going to go to the cloud. Even if you're going to go to Azure, there is one endpoint, they call it, which is just a web address, right? One web address they're going to go to, and they're going to use the highest level of security that's out there right now that even the DoD is requiring, which is using this transport layer security TLS 1.2, and that's the latest. And we'll continue to move that forward and upgrade it as you go. But the nice thing is the IT department, even if you were going to the cloud and embracing that part of the solution, is only going to have a single endpoint to deal with. And it's this simplicity, it's this limiting of conversations that has allowed us to go into the Defense Department. So that's got to give you some confidence back to your small to medium suppliers that we're very aware and very sensitive of the security issues of this and are working with NIST to make sure that we're keeping them compliant. Okay, sorry, I've got a sensitive mouse here. So what does it look like to connect? So what would happen is there's this tool called Solution Builder, which I'm about to give you a demo. I get tired of slides. I want to see it working. And that's what I'm going to go to here real quick. Thank you all for being patient. But I'm going to take Solution Builder. I'm going to load it on any PC I have, right? So I've got a PC. The nice thing about this Solution Builder, which is the configuration and visualization tool for the LIMS box, it's free. You can give it out, put it on your web page. The only thing you agree to when it starts up is it's free and will always be free. And if you'll do that, then Solution Builder is free. You'll connect to it. You can either connect on your manufacturing network, which is the green network. Hopefully you can see the difference, or the blue network, which is your business network. Solution Builder can run on either one of those, and it is going to use that single port to connect and get all of the data and do the visualization for you. So we might have a machine tool that we're going out to. Here's a 5-axis router, and we have an IP address for it. We're going to give the IP addresses, the exact network address for each person in the conversation. And then we also will say, here is where we're going to go out to the cloud. Here's IP address where we're going to go out to a SQL server where I might be storing my manufacturing data that I want to look at for historic purposes. So those are some examples of what's happening. And the other thing, so once we've gotten a box, this LIMS appliance, it can be overwhelming. Maybe we're doing too many things. It gets, when you first look at it, you're like, wow, that's too much. So what we want to do is really break down what we need to do with the box into 5 basic things. The first thing is to connect to your equipment. So I've got a printer, hey, I've got a shot peen booth, right? Well, what do I need in the shot peen booth, Nat? Well, I need to know what pressure air supplied to that shot peen booth to make sure that I can reach the surface finish I'm looking for. I want to know the temperature and humidity in there. Or maybe I've got a paint booth and I want to know the temperature and humidity of and the pressure that I'm painting at. So that might affect long-term ability for that paint to adhere to the surface. So connect to the equipment. Second thing is to apply some simple analytics or machine learning. And I want to be able to do that. I can do that locally. And I want to be able to, I call the little engine that I put in the software a statistics engine. So I don't make the people that are in big data angry because, they have all these big words to describe things. And remember, I'm a mechanical engineer first. I usually have a screwdriver in my back pocket someplace. And at the same time, we're going to give you what I call statistics, things that I would normally dump the data into Excel and do some regression on quickly. So that's really what we're doing, which I'm going to say that that's not big data, but it's data you'll probably use first. Third step is collecting that data. So now I've analyzed some data. Maybe I just converted a piece of data from some number into engineering units in my analytics. Now I want to take that data and collect it. I want to collect data from my machine tool or from my homegrown sensor that the students are working on a project. I'm going to collect that data and get it out quickly. And then finally, I'd like to be able to report the data, maybe send it back up to the cloud. I want to store my history for my jobs out to the cloud, so we can do that. And then 5, near and dear to my heart, is to control the process. I want to be able to do something simple as tapping you on the shoulder with a text message when your machine tool went down, so that you don't have to keep your eye on it. Maybe a stack light, sending an email, or going out and controlling equipment. So those are the interesting things in controlling the process. So now what I'd like to do is stop with the slides, take some quick questions, but now I'm going to go on to a demonstration of how this works. And hopefully you'll see there's some simplicity in this. And that's what the rest of the day is about, is looking at what you can do at a local station with some simple sensors, and to be able to, or even do just some simulation of data and maybe create a simple rule that might turn something on or off. Those are the things that Larry's going to be walking through you with, and walking, and kind of holding your hand through this afternoon. So any quick questions before we jump into a demonstration? Okay. All right.
I have one question.
Yeah.
I wanted to know, you've got a bunch of analog outputs in here, but I don't see any analog inputs. Is that correct?
Yes, there's 8 analog inputs on the box that you have there. The black box inside the LIMS box has 8 analog inputs and 8 analog outputs. So the goal here is the nice thing about the analog inputs is they're universal, and that buzzword in the industry is that they can have lots of different electrical characteristics and have come in on the same screw terminals. So when you in software tell it that the first sensor is a 4 to 20 milliamp sensor, and the second one is a dry contact, or just a contact closure, it's going to adjust the resistors to do that. So they're on the black box that's there. The reason that black box is there is it has 8 universal analog inputs. It has 8 analog outputs, and then it has some relay outputs, which will allow you to affect things. And you'll see those as green lights that might be flashing on or off when we run that box.
The reason I'm asking that is, if you have a PLC with a PID loop running a process, we could almost eliminate the extra cards we need by using this and send the data to the PLC to go through its PID loop. Is that correct? Or
Exactly. Yes. So you could have the PLC running against data that you're supplying, right? So that's good. You're thinking down the right way, right? The first thing that we were able to do with for the Army was we lowered the cost of the PLCs they were buying. And the reason for that is we didn't have all of the memory needed to hold the entire process in place. And second of all, you could add a couple IO sensors on via the LIMS box without having to buy new, you buy IO for industrial PLCs in large chunks, and it may be prohibitive. The nice thing about the black box that's inside that LIMS box is, I think in retail, it's $139. And that gives you 8 analog inputs, 8 analog outputs, and 6 relay outputs. If you've been in industrial automation, you know that's cheap. And the nice thing about those black boxes is they're networkable. So if you want to have some IO around a particular machine, the only thing you need to add is another one of the black boxes to get the data from the machine, and you don't need to add another LIMS box. The LIMS box is a computer. When do you need to add a new LIMS box? When its processor percentage is too high. It's a computer. So when you're using 95% of the computer, it's probably a good idea to think about having a second LIMS box. The software naturally networks it. So you can't even tell, except you just need to know which sensor came into which LIMS box. But you can add additional IO onto the system without having to buy another LIMS box. And really, you need to get 24 volts to get that IO module running. But yes, you can work this interactively with a PLC and add more data to the PLC, or even pull some of the logic up out of the PLC and do it in the LIMS box, which would allow you flexibility and to keep your manufacturing engineers from having to become PLC programmers to pull something off. So that was the goal of this.
Great, thank you.
Okay. And now I'm going to jump over to the tool that I have been talking about, which is Solution Builder. Now, the question is, can you all see any of that? Can you read LIMS device 3 on the left-hand side?
No, you're seeing the slides still now.
Oh, stop share. I tried to share my screen, share screen, and well, show all windows. I guess that does it. Share. Okay, now can you see Solution Builder and LIMS device 3?
I think so.
Yes.
Barely.
Barely.
Yeah.
Okay.
Wow.
Let me try something quick. I'm going to stop share just for a second, and I'm going to lower my screen resolution. And we're going to go down to something a little bit more comfortable. 1920 by 1080. Keep changes. I'm spoiled. Yep, there we go. And let's see what happens. Oh boy. Close. Let's see what's happening here. Oh, I don't know. Maybe I got into trouble there. Let's see. Sorry about that. Keep changes. It won't let me do it. Okay. Let's see if I just share my application, but keep the application smaller. I don't know if that works or not. I'm going to try that. I'm going to share the screen again. I'm going to go back to get Solution Builder running. Okay, and okay, I'm going to make that. Okay, is that any easier to see?
Yes, it is.
Okay, great. So then I just will make it smaller, so that should work. Okay. Okay. Now we're in the tool Solution Builder, and I'm my design goal was that this stays simple. And you all at the end of this will tell me whether we met our goal. Now, I've got a lot of work to do because I'm really thinking about the 5 things I want to do. Connect to some equipment, analyze the data, collect it, maybe report it, and finally do a little bit of control. And I'm going to do those 5 things. And you may have seen some videos already. I'm going to walk through this. Obviously, if you have questions, this time is yours. If I'm not clear in an area, please stop me and get me going. But what I'd like to do is the first thing we have done is I do know that people aren't going to have the resources to hire somebody at a good technical level that might be able to do any programming or things like that. But what you usually are doing is handling wizards, right? So what I've done is taken all of the connectivity that we've done in the additive marketplace and made sure for every machine that I got to that it's a simple wizard that you run through. So for both additive and subtractive, it'll be similar. So if I have a machine that I'm interested in, and let's say it's a desktop 3D printer, they're usually running this interface called Marlin or Octoprint. Then in bringing that out, you would just say, hey, this is my new printer. And at that point, you would identify the serial port that is connected to inside your machine. And once you've done that, you can connect. The other thing you can add to it is whether you had any data items over in the tree that would be for looking at the power consumption of the machine, called a current sensor, or if you got temperature and humidity coming in. So all of those are added by just adding a simple wizard to here. And Larry's going to walk you through even more of those wizards later. But once I'd add a machine to the wizard, it now appears in the tree. So what is the tree? The tree is a list of everything that I've configured. So if I think I come into Solution Builder, I just configure the equipment that I might have that might be commercially available, or I might go configure some IO, and we'll look at that in a second, of bringing in additional data that's coming in. So I'm going to run through some wizards, and it's going to cause devices to be built in the tree. Because I connected to a Marlin printer, and I've got a Prusa off my shoulder, if anybody's familiar with those, it has created a device called Prusa. If I take Prusa and just drag it to the display and look at everything in it, I can see the Prusa and its axes and the current job it's working on and its temperatures. So that's great. So as I see my Prusa piece of data and I want to look at the extruder, so there's a hierarchical tree of the devices I've run through wizards. So again, all I need to do is be able to navigate a tree, and let's see, I want to see what the current extruder temperature is. I'm going to graph it. So again, I'm going to try to create some dashboards quick. Let me remove this, remove that. So I'm going to take the target temperature that I've given the extruder. I'll bring that out. And right now I haven't told it to do anything. And now I'm going to look at its current temperature. I'm going to take those two and let's put it on a graph. Let's add the second temperature to there. So again, people without having done any programming, haven't done any programming so far. All I've done is configured a connection to a machine, and all of a sudden I've got some really, really great data. Now what I'm going to do is I'm going to go ahead and start the printer printing. And it'll go ahead and get that working. I'm going to remove my old print here. Sorry, I was testing something this morning, so apologize for that. Oh, all right, let me pop that off. Okay, there we go. So anybody who's done 3D printing knows what I just went through. There we go. And now we're ready for that, the bed starting to heat up. We see that the extruder temperature is starting to come up here, and then we'll see our target temperature come up as well. We also, when you're doing 3D printing, not only do you see the bed and things like that, we're also, we have an extruder that's just taking some plastic and heating it up and then basically just kind of squeezing it out on like a tube of toothpaste, squeezing it out and making a part, right? So I'm oversimplifying it, but you get the idea. But this is connectivity. We connect to our machine, we start getting data, and all of this data is available for us to do whatever we'd like with. So I came in, went through a wizard, say I've got a 3D printer, student would like to get started and looking at that, and now all of a sudden they've got all of the data that they would like to see from that printer. I've got a bed. So the bed is the base where we're going to be printing something, and it also has temperatures. So let's see what the bed temperature is, and we can bring that temperature out to the screen, and we might make a numeric out of that as well, and then figure out what the target temperature is for that. So this is the process of connecting to equipment and starting to look at it. And the goal is all you had to do was run through the wizard, and all of a sudden, all of this kind of data is available to you. We wanted to give them some quick out of the box experience and having data from their systems and for it to be able to explain itself. So over on the left-hand side, all of the data as we go to configure that, and that might be just from an external printer, and all of the data that's available from there is all available in the tree, and all you've got to do from that tree is drag it over to be able to see what's going on. Let's say, and that printer is going to be busy printing behind me while that's going on. You'll probably hear some background noise in doing that. But our goal is next, now we've connected to some data. The question is, what if I'd like to add a sensor to that particular data to come in as well? So all of these protocols, so the connection to printers are established by a particular model or brand of a printer that you're working on. The IO coming from the system might be coming in through those black boxes, which is Modbus. Is there a thermostat on that system as well there, Larry?
On mine there is. I'll show them one later.
Okay, so we could be connecting a simple thermostat, or we're taking Modbus and we're going to be bringing in some IO. So there's that T380 Ethernet that's in my LIMS box. It's in every LIMS box we build, and you can simply edit the inputs. Now I can tell it what type of input is on screw terminal 1, and you'll see lights right over screw terminal 1. There's input 2. These are the analog inputs. So I can say that's 0 to 5 volts, or it might be a 4 to 20 milliamp sensor. So you just drop down, or it's just a contact closure where I'm just going to see when a switch gets closed. I can just say that's on or off. And all I have to do is save that. And all of that data, like my printer, appears in the tree. So if I look now under Modbus TCP, under my T380, I have simple inputs that are coming in. I'm going to add a second page to my display. I can add as many as I want, but I can look at all of the data coming from that black box and the analog inputs that are coming in, and the values for those different inputs are all available here. Digital outputs. I've got some lights that are going behind me. I maybe want to turn those on or off. And I don't know if you're seeing the lights behind me, but I can simply play with the lights. So I have a digital output 1, and I make a push button out of it. And I see that that value is currently set. If I turn it off, it gets turned off, and that might affect a light or something that's going on behind me. So the connectivity to IO is always done through these simple wizards. So you don't have to become a programmer. All we had to do was, once you decided to buy a certain sensor, to go into the configuration and edit the inputs and tell it what type of data is coming in, and it'll go ahead and bring it into the tree for you, and all of that data is available. So that's the getting started guide to just connecting to some equipment and bringing in some sensors. Now, the second step that we wanted to do was to be able to analyze something quickly. So I have, let's just take a simple piece of data that we have created. So within the LIMS box, you can bring in IO, we can connect to pieces of equipment, but we can also create what I'll call virtual data. So in this, I can easily add a device, and we're going to call this my test setup, and I'll create that device. And this is just a virtual device. So if you think about bringing in data, I want to transform it, I may want to do some calculations and push some data back in. All you do is create some virtual devices, and then I'm going to add a data item, which might be my answer 1, and it's just a number. So again, this was designed for non-programmers. It's either a number, it's an on-off value, it's a date and time, it's an integer, just a counter, 1, 2, 42, or it's just some text. And you can simply create any kind of data you want in the system, and we could choose to do a calculation here and push data into it. Or you could be on an external system in some code that you're writing on another platform and push data into answer 1 here. So let's take answer 1 and put it up as a numeric value, and it's currently 0. And if I want to set it, I just double click on it and set that value. If I want to change an output on my digital output, I just double click on it. So again, the goal is to keep this simple. Any data that you configure into the tree, or any machines you bring into the tree and drag out, you're immediately able to see that data without any major work. It's just a simple dashboard that you're bringing up onto the screen. So we've got this answer that's going on. Now I've got an answer. What I'd like to do is to, usually when I'm bringing in data, it might be noisy. It might be changing too fast, and I want to filter it a little bit. And that's where we started to think that I needed to do some statistics. So if I look up onto the tree, I created this little statistics service. And I'm going to add a new group of statistics. Let's say that answer that's coming in, I wanted to filter it. So this is my answer statistics. So I'm going to add some answer statistics, and I'm going to select the kind of calculations I want to do. And let's do something basic. I just want to do some average min max. I might want to look at a rate of change. How quickly is a piece of data changing? All I do is click on that. And now it's going to do all that for me. And it's asking me, tell me which piece of data you want to do this on. So I'm just going to go over and tell it to do it based on answer 1. And its current value is 42. And I'm going to save that. So I brought in some data, whether I brought in that data from doing a wizard to connect to a particular machine, brought in some IO, or I went over and did some calculations in a whole other system and moved it in. I want to bring that data in. And now I've got a whole bunch of new statistics that are being calculated that didn't exist before we started doing that demo. And I see my new answer statistics, and it's looking at an average, and it's doing a calculation on that answer. So let's change the answer to 44, and we'll see that data is starting to move. Now, what I'm going to do is I'm going to take the original piece of data that we were working with in my test setup. I'm going to take answer 1 and I'm going to graph it. And then I'm going to take my answer statistics and look at maybe a moving average that's being calculated. So now let's go ahead and play a little bit with answer 42. Let's make it 50. We'll see it change. And all of a sudden, we're going to see that moving average move along with it. So this gives you a chance to bring in data from any kind of sensors or any other system, and you can a la carte quickly select some different statistics that are going on. And that's what we're seeing here going up on the screen, and you can graph it, dashboard it, and things like that. So again, we bring in some data, we do some quick analytics on it if it's necessary. If not, you just bring the data in as it is from the wizards. And now the next step we might want to do is to go ahead and take that data and start collecting it. So I'm going to go ahead and open up a data collector. So I'll bring in a new screen, and I just keep adding tabs, and you can rename these tabs, but I'm just going to say, I would like to collect some data, and let's do this answer data. Okay, and you can even spell it wrong if you'd like to. But now I'm going to take all of the statistics that I just created. I'm going to take the test setup answer that I got, and any data I'd like. Let's also go over to our Marlin printer, take our Prusa, it's busy back there, and let's bring in the target temperature from the extruder and the target temperature and the actual temperature. I'm going to take all of that data. I'm going to tell it, hey, every 5 seconds, I want you to collect it. I'm going to save it and get that running. So I've connected to some data by just running some simple wizards. I've created some new data by doing some quick statistics on something. And finally, I'm collecting that data. And that is the steps that we just followed by just dragging whatever data you'd like out of the tree and putting it into a data collector. And you're like, Nat, that doesn't help me. I'm not a database person. I don't know about databases. I'm not writing code into a database. I got that. So now we're going to look at the database that's being created. So if I look in my SQLite, I got a new database inside of it. So there's a tab that looks at databases that you connect to. And it said, you have a data called answers data. And there's all the data that's now being collected based on that piece of data, that that statistic that we created. So if we go over to our display and change our answer to 58 and see that it moves, and then maybe I'll change it a little bit more back to 42, and all of a sudden data is moving. If I go back to my database viewer and refresh it, I'll refresh the table, then new data is going out, and we'll see that data was changing, and new data is going out to my data collector. Again, I'm not a database person, Nat, that doesn't help me. Why don't we just export all of that data over to Excel? We'll save that, and now we can go open that data up into Microsoft Excel and do whatever we'd like with it. So again, the steps were connect to a piece of equipment like we're doing here with the extruder. We might want to look at its axes moving or something like that. So even this, this printer has, for its current jobs and its axes, I might want to look at its axes positions, and I'm watching them move back and forth. All of that data is here for me to do anything I'd like with to start understanding my process. Second step was we did some statistics quickly just to calculate a moving average on a piece of data that we're looking at. collected some data to a database by just dragging out a window, dragging the data that I'm interested in and having that go out to a database that I can look at and export to Excel. And while I'm continuing to talk, that data is continuing to be collected. So again, we're making a lot of steps. But the other thing you could look at and say, Nat, this is overwhelming. This is too much and I haven't even finished yet. The next thing I do is control something. So the question is, what is it doing automatically based on it told it had a printer? And that's all I did. If I just went in and said, connect to my printer, bring that data in and leave me alone, what does it do? So let's take a look at what it does automatically. This is the out of the box application by you just configuring it. One of the things that everybody's looking at is, I just did a print job. I'm printing a particular part. I would like to group all of the data for that part. So if I take a look at a particular job that I ran on the 10th at 2:46 in the afternoon, I can take a look at all of the data from that run. There's the extruder target temperature. There's the actual extruder temperature. I can see how the filament was being used or the X, Y, Z positions. So for the LIMS system, as you bring in a particular machine, a type of machine, will classify the output for that machine and store every job that ran into a separate job history that you can bring back and analyze for looking and comparing what a system is doing over time. So this is automatic. You didn't have to do any of the things I did by statistics, data collection, or anything. These things happen automatically. And that is that you have a history of all of this. And for the computer scientist in the room, that data is saved out into a format of JSON so that it can be ingested into machine learning. And you can do, the students, machine learning folks can learn from your processes, compare them, and let you know when something's changing, when your process is very different than it used to be. So what we did by you running the wizard, we're doing calculations. We're looking at the utilization of your machine. We're looking at, and there's the utilization graph that's coming in. So we're seeing how you're using that equipment. So by you just running a wizard, we automatically are doing a lot of things of production monitoring that you might want to do without you spending any other time with the product other than looking at the results of this. So there's a lot of, it is a great engineering Swiss Army knife, then that can be overwhelming. It's awesome for students. They will play with it. They will get data out of it and things like that. But for that small to medium manufacturer, this was the killer app. The killer app is you've got a history of every production run that you made. Every part that you made, you've got all of the data from it, and you've got the production monitoring of your equipment all stored for you. And you didn't have to do anything other than fill out that wizard. So that was the result of all of the internal data that's being stored, and the whole mechanism to do this was created because you ran a simple wizard on a particular machine. And that's how we get started. So I showed you the steps of connecting to a piece of equipment, running some statistics. Yep.
Okay, a question came up. So where does the data reside?
So this data is stored on the LIMS box, but you can configure the LIMS box to, as that data gets stored, and the data is stored off into a separate file in a JSON format. You can individually move those pieces of that job history. You can save it to a file. You can export it to Excel, or you can delete that job history. You can configure the LIMS box to automatically copy any job history back to a network share location that you might want, so you could have all your machines collecting. Or you can take tell the LIMS box after 30 days, after 90 days, I want you to delete the old job histories from the LIMS box, because the LIMS box has a finite amount of space that it can use. So this gives you those individual job runs are stored in a package that is easily ingested into machine learning. Sorry for that ugly word. That just means they can load it up and it self-describes all of the data is inside of it, which makes the machine learning folks happy, because most of the projects to do any kind of analytics on this data is about, one, trying to get the data generated and then figure out what the data is. We took care of all three of those steps. We connected, got the data, we have it self-describe, and we save it out in a format into a package that you're easily able to bring in, so the students can easily bring that up, load it into Python. It's self-describing JSON data, and it's automatically an object with all of the different fields defined for them. And that's exciting for, you know, folks that are in the computer science area, I think. See if there's any testimonials in the crowd there for anybody who's in computer science. All right. So that is job histories. And that was the point of simplifying the process down to simple wizards that you can go ahead and run, connecting that printer that's busy printing back here, or the robot, or a CNC machine, bringing that data in. We do the same thing with CNCs. So if you want to look at a particular CNC run, and we look at the data coming off that run, and I want to look at the X, Y, and Z positions, that data is available for every different type of part that's created by the equipment that the LIMS box is connected to. And that is the free app that comes along with doing it. The rest of the work that I'm showing you here to dashboard, see what's going on in my system, is when you want to look inside and figure out, do your own data acquisition, do your own statistics, add your sensors. So you can see the first thing is to get the box in, to get people comfortable with data being created. And then the second part is start to create your own data, create more data. Continue to expand the the hierarchy of data that's available on your process, and all of that's supported, whether they just want to get it in, connect to some equipment and leave me alone, tap me on the shoulder when my machine stops when it's not supposed to, let me know when a temperature's over, you know, a spindle temperature, motor case temperature is too high. We can easily do that, and that's one level, and that's all they're willing to support. Or you can enable some students or enable an engineer working at that location that really wants to do some investigation. The goal of the tool, which is Solution Builder, and the box, which is LIMS, is to empower you to be able to do that. So any questions on that? That was a huge fire hose. There's one other piece that I want to show you, which is to how control equipment once you've done that. But I wanted to see if you have any questions right now on what I just presented.
I have one. What is the maximum sampling rate you can get out?
So with the operating system itself, I would expect to do no sampling faster than 100 milliseconds. It's a Pi system running on a quad core ARM, and that would probably, from the operating system scheduling capability, be your limit. Now, the operating system has a real-time extension. So and it has some direct input IO, high-speed inputs that you can attach to the system. If you connect to that, the real-time extensions can be doing high-speed sampling, buffering data, and then you read that out at an interval with the timestamps from the processor for real-time data. So I don't think you're limited. The real-time extension has the ability to be scheduling in the hundreds of microseconds range. Okay. So it's overwhelming. Can be too much. The question is, how do you keep this simple? And I think that if you showed a small to medium that you can connect to your equipment, to most equipment out there, you can connect to it, you can bring it in, we'll add a thermostat just to let you know what the temperature and humidity in the area is. We get your coolant temperature, bring that all together, and then record it and show them that they can see the recordings. That's a big start. That's a big first step. And if you can look at your different pieces of equipment and bring them out on a screen, we'll add another display here. And I'm going to look at my production capability here, and I see that my Prusa is running, and I want to see what its statistics is. I would like to see its current utilization as a number, and maybe I have 10 machines that are out there showing me their utilization, and I'm going to make that I'm going to graph it. So I can take all of my pieces of equipment, show me what they are. This is rounding error in the calculations right around 100%. And now we just shut off the piece of equipment. That was perfect timing. And now we'll see that start to decay. Those are the kind of things that you can do basically kind of out of the box, free. We can monitor on that Modbus 0, you're going to see a thermostat come in, and I want to see the temperature that's coming in. That temperature is over here, and I'll put up as a numeric as well. So if I've got that kind of data of the production of each machine, the temperature, humidity that's going on, and I know that I have all of that data saved for every production run, they can do that when you're there connecting to that piece of equipment in a couple hours. And that's a great first step for this digitization and their digital transformation. Because in order to be able to come there, we had to have a conversation with whoever manages their IT. Majority of the time, that's contracted out now. And we got them ready to start getting data moving around their facility. And that's a huge step. All they had to do on site was run one of the wizards, whether they had a FANUC CNC or a Haas or a Mazak or an MT Connect machine tool that they were connecting to, or they went and added one of the different types of AM printers, the additive printers that are coming in. And then all of this data and looking at utilization, looking at data that I'm collecting and knowing it's being collected for me without doing anything is a nice first step. And that's really what we designed, the LIMS box, the software around. And our goal with AMI is to give them that quick experience, right, of being able to connect some equipment quickly and get some data out without a heavy investment on their side. That's the design of what we're doing. And the goal is this tool gives you a quick way to dashboard it really quick and to be able to see what's going on and then be able to do something about it. Can we do some quick control? So I'll show you quickly what control looks like. And it's a simple thing we call rules. So I'm going to look at a simple rule here, and Larry's going to show you some more complex rules this afternoon, I know. So I'll leave my utilization graph up, but I'm going to look at a rule. So I got frustrated with the PLC folks becoming the keeper of the keys, I call it. That in order for you to make a change, you usually had to write a contract to a consultant to come in and do something for you. What if it was as simple as defining a flow chart? I want to turn a light on. I want to wait a second. I want to turn that light back off, and I'm going to loop back up and do that. This is dumb simple. But now I know that I connected to a T380, which was that IO box, and the digital output 1. I just want to turn it on, and I'm going to also turn on digital output 4. If I wanted to turn on another digital output, I could go to my Ethernet, and I'm going to take digital output 5. I just drag it in, and I want to turn it on or off. It knows that it's a digital output. I create the rules. I can add more steps to the rules, just add another step. This is a air step. And then I can tell it to go to that particular step after I'm done doing something. I can say, go to a particular step, and it'll ask me which step do you want to go to. So you can make all kinds of simple decisions. I'm going to delete I'll delete that step. So we just are going to turn on, turn off, and loop back up. I'm going to save that rule and get it running. And now you'll hear some clicking. I don't know if you see my things going on behind me, but once I'm done with this, you'll see that I've got some stack lights that are turning on or off because I wired them up to those digital outputs. Digital output 4 is going to a green stack light behind me. So my print finished. I've got a part right here. Good timing. And I can go to my job histories and look at my LIMS device and look under material extrusion and see that I got a brand new 120K file that has all of the data from that run, and I can look at its bed temperature, extruder temperature. All of that data is available to me for that entire run here on my machine. I can see this shop humidity. Here's the shop temperature as we were going on, holding pretty steady. So all of that data is available, and I can take that data and save it off and give it to my machine learning friends and have them go do some analysis on it. So that is the part that just finished running here. It started running at on the 21st at 10:55 a.m. is when I started the job, and there's all of the data that's available. So this gives us, again, we went through the process. I'm going to go back to the slide. I think I'll have to check over, go back over to the AMI presentation, and probably have to switch my display, stop share, and I'm going to start sharing again. I don't know why it's not sharing my entire screen, but there we go. So again, we connected some equipment by using simple wizards. We applied some analytics by using that simple statistics engine just to do some averaging on a piece of data. I collected data to a database, exported it to Excel because I'm a mechanical engineer and I'm not a database person. I can report data up to an AMI cloud. That's another process. And finally, controlling the process by maybe just having a simple rule that's turning things on or off. And all of that's done through this single tool called Solution Builder. And you can have multiple people from multiple different reasons or multiple different roles. So I may have somebody from maintenance. I may have somebody from operations, all of them looking at a process and my different pieces of equipment differently. Engineering's looking at it because they've got a temperature problem, a coolant temperature problem in the afternoon as the sun comes in on a particular machine. I want to see what that coolant temperature is because my parts are starting to grow, anything like that. All of those are simple things that can be done. But the most important thing we did was we started with a wizard, and that wizard's producing a whole lot of data for us that we can analyze our process. And if we figure out what's going on with that process, we can finally go back, maybe make changes. We may do a tool offset adjustment or anything like that. And we can do that simply by, from the rule, dragging something in and making a change to it. So that's kind of an overview, a quick demonstration of it, and also an orientation to why the system and the appliance is really designed the way it is. And hopefully you feel that it's kind of approachable. Nat, that was way too much. But if I saw that in a video, maybe I could do that myself. And that's what we've learned is YouTube videos of doing this kind of thing are really important to provide somebody. And look, when I have the dishwasher go up and there's a clip that's broke, I go search YouTube real quick and figure out how to do it and then just apply that myself. So that's really the approach that we're taking here so that we lower the investment. Our job is not to create a huge dependency of them needing us and our, we're small teams. What we want to do is really be able to scale. And I think the scale in that strategy with AMI is also to involve the universities so that there are teams of students that understand how to do this and they go out into industry with this skill set, not starting over on every project, trying to get the data from the same piece of equipment. But they start that project by being able to connect to the equipment and concentrate on the engineering problem. That is the purpose of the LIMS box and the solution family software. So I'll stop for questions.
Yeah, I have one. I was wanting to know if I've got some data that I'm bringing in, say, off of a sensor, and you had some rules in there. Can you set that up with some mathematical formulation, come up with some new values to send to, say, a PLC to change its PID loop and adjust things, or maybe a better way would put it to calibrate something,
Sure.
Calibrate this?
Yeah, so the rules have quite a bit of capability. So you can add in decision tables. You can do simple math. You can add an equation, and the equations are basic equations. If you wanted to do some heavier calculations, you may just create a little adapter, which are these pieces, devices that appear in the tree. Because adapters, we have a bunch of adapters that also do random number generation. You can build text. We've got a simulator into here, or you're going to build some JSON text that you want to send out. But you can build more. We've had NASA extend this. We've had GE extend this to be able to add some very complicated equations you might have. You could add those through a simple adapter. And then you can send that data back to the PLC. Yes. And the PLC, you might go connect through OPC UA or OPC and connect to that PLC and connect data directly to it. We can connect to Allen Bradley. If you had some cheap Allen Bradley PLCs, you can go and directly write to the data back into the PLC. So yes, all of those scenarios are available, and you can use rules to be able to do that. We've run entire nitration processes at the Army through entire buildings with maybe 100 rules. One rule can call another rule, so you can cascade them and create control, and been able to run very complex processes over different buildings with rules. And the rules are just a way for you to describe some logic. If there's a very strict mathematical calculation, we may bury that into an adapter and just call it, as opposed to try to represent it in the simple rule form. And you could just call that method in, let's say you loaded the library, you can call that library from within the rule, have it do the calculation, and then take that calculation and feed it out to the PLC.
That's great. The other side
Is that said, sorry, Sam, is that said, we'll do a kind of a simple rule,
I was just looking at this because we had this, you have the simulation piece in there I saw. So I could actually set up a temperature control simulation, and there's what it looks like the way you have it set up.
Yes.
And I could run some values out so the PLC is receiving those, and then have the students learn to control that. Is that what you're saying?
Absolutely, yes. Yes, and so I'll take a rule and do a simple simulator of a device, and it's not pretty. It doesn't have to be the most complicated simulator, or you can build a more complicated simulator in a little bit of code, a couple lines of code, and then bring that into the rule and populate some data items with that. Yes, all of those are what we do with the system.
Excellent, thank you.
We have simulators for simulating. We actually have playback capability to simulate devices. We have playback capability for GPS locations, for running routes. You know, it's really wide open what you want to do with it. And we give you simple examples of how to write your own adapters. So you're not limited by what you might want to dream up.
Thank you.
Yeah.
Yeah, a simple networking question that somebody asked me. So I have all the demo setups here connected to routers, right? A simple TP router. Why a router and not a switch?
Okay, so the LIMS box itself is, we can either set it up as a static IP, but given most of the demonstrations we want to do, we usually have, it's going to give the address to the LIMS box, and that's DHCP, where it's dynamically giving it the IP address. And we are using that for the LIMS box, so it requires a router. If in the plants, we can simply steer the LIMS box to a static location, then you don't need a router.
Thanks. Other questions for now? Remember, he's the expert. So you will ask me questions that I can't answer in that problem.
Larry's being modest. He knows this. There we go. He just lets me answer it.
I think we need time to play with it to get some questions going, so.
That'll be great. Yes, and I'll be here. I've got some things to jump off on, but I'll be here in case you stump Larry. He can certainly reach out to me, and we'll come back in. But we'll, you know, and we see this as an ongoing process. So as you're taking this back and you're formulating questions, we're going to be there to help back you up. And I think the goal is to formulate those questions into something that I could do a quick video against, because the goal is to raise all ships, right? So we want to be able to have all the universities share in the answers to those questions, right? You know, and all of the colleges to be able to have the same access to that. And if one's asking it, it's probably good for another one. So we'll start doing a series of YouTube videos to be able to get the answers to those questions into one location. Or if there's something that you feel is a little problematic, you'd like me to do a video on, be more than happy. I think in this thing, so it's easy just to start recording and let me, you know, give you a demo of a particular problem area you're looking at. Okay.
Thanks for all the information. Appreciate it.
And for the students, tell them to go to GitHub, because I know if they're in computer science, they know what that is. And it's Solution Family, And if you go to Solution Family and GitHub, you will find all of the SDKs, the open source SDKs for taking external systems and connecting into the solution engine. If you're not going to just use the MT Connect, which is a standard that's already there, that's a way to do it.
Okay, thanks,
Okay.
Dad.
All right, Guy. Good luck. Have fun, and look forward to getting some feedback. That's wonderful.
All right, great, thanks.
Have a